volume on that. Okay. Can you hear me? Okay. I do have a mic, but I'm not inclined to use it more. Is that better?
Sure.
Yes. Okay, so yes, I'm Holly. Thank you for letting me give this presentation. I'm pretty excited to talk about all the work that's been going on here. Just to give you an idea of what this session as a whole is going to look like. Dan approached us a few months ago about putting together a whole session on Otsego Lake, given its storied past, and we have a lot of data that we've been collecting over the years. So I'm going to start off with an overview of that history, and then bits and pieces of that will be elaborated on in the talks to follow. So hopefully I will give you all the details you need to follow along with what's going on without getting hung up on any one part for too long. When I first heard that this was a 2-hour session dedicated to the lake, I thought finally there's enough time to tell the story, and now I'm trying to fit it into 15 minutes. So that being said, I'll give some acknowledgments up front. As anyone in this field knows, that none of these larger projects, long-term data sets are compiled by one person. I certainly have not been here collecting data since 1935. And so really thank our partners. We're constantly working with DC, Region 4 Fisheries, as well as folks from Albany coming out to talk about long-term planning for the fisheries side of things. Cornell has done a lot of work here. We're working with Mark, obviously, SUNY Cobleskill. We have a lot of really supportive members in the local community. The Otsego County Conservation Association in particular has put in a lot of effort over the years to help us fund the walleye stocking program. And we've been very successful with some NSF grants to help us build up our infrastructure. So with that, we'll get going. And just in case you're not sure where you ended up in your travels, here we are in Otsego Lake. And I bring this up because the location of Otsego Lake is kind of notable in terms of how it differs from other lakes in the state. So we have obviously a lot of people working in the Finger Lakes along the Great Lakes drainage basin. Otsego Lake is similar in its formation to those Finger Lakes, but we're hydrologically isolated, so at the top of the Susquehanna River Basin. And this is important in terms of thinking about food web because we are somewhat isolated from the effects of invasive species, especially those that are being transferred between Finger Lakes and some of those more connected water bodies to the west. We're also distinct from the Adirondack Lakes and have been fortunate not to have the impacts of acid rain over time. We have a fair bit of limestone in the watershed. So that just sets the stage. We're a little bit different, but we're similar to some of the other lakes here. About 9 miles long is the length of the lake, 170 feet deep. And in terms of the native species that we've been concerned with here, with management, we have a strong lake whitefish population that's on the rebound, as you'll find out, and a native lake trout population. So those are the two species of concern as of late. Over time, the management of the lake has changed. The focus has shifted from one on nutrient management and nutrient reduction from sources in the watershed to more of a focus on trying to find balance in the food web. In the mid-90s, when the lake management plan and local partners were getting really involved with the development of a lake management plan, up until that point, a lot of the change in the lake was related to the incoming water quality. We had nutrient sources in the watershed, in particular wastewater treatment, that had a drastic influence on the character of the lake. As we were developing that plan, we thought the changes going on, the algal blooms that were developing at that time, were also nutrient related. Little did we know that there was a huge influence from the food web at that same time, but enough time had not yet elapsed to really appreciate the influence of alewife on the whole food web. So you'll see this whole story play out, hopefully. Here, if I can get up on this slide. So fisheries management has always focused on kind of taking advantage of differing abundant forage fishes and none of this adaptive management over time would have been possible really without a lot of institutional knowledge. I think that is really underappreciated. There's a lot of times where we're talking to each other about, hey, do you remember that study? And little bits and pieces of information get lost that we find are really critical later on. So while we think we're really good at record keeping, I think it's really a lot of people that make these long-term data sets happen and realize the connections over time. And we've also had a lot of people that really have worked together very well and continue to do so. So we'll get on with it. We have a lot of data that's been collected over time. Can't show all of that, nor would you ever want to see all of that in one place at the same time. But we see a lot of the changes in character, a lot of our major points in time are reflected in our transparency data set. So here we have from 1935 on the left all the way to the present, mean growing season transparency. And the first notable change that we see related to a management activity was back in the 70s. A major wastewater discharge was eliminated and transparency dramatically increased. As you would expect, you reduce the nutrient loading and the algal growth is limited, and we see rebounding water quality. And so the history was there to manage nutrient sources to improve the transparency in the lake and to control algae. Well, in 1986, alewife were illegally introduced. They were intentionally but illegally introduced. And after that point, we see declining transparencies as this fish influenced the food web, and it ultimately mimicked the same effects that we would have had from nutrient loading. Later on in time, the walleye stocking effort began around 2000, and we saw transparencies level off. Zebra mussels came into the picture around 2009, right around the same time that we were starting to get a handle on the alewife, and our transparencies drastically increased. So this long-term data set really is one of the more simple measures that we have, but we can track these major system changes through over time. So now we'll focus mainly on the fisheries side of things to set up what our food web looked like. We're focused on the alewife invasion and the control of that population through walleye stocking today, but the alewife was not the first non-native species to come into the lake. The first major introduction that caused some shifts in our lake whitefish population were the Cisco. Those were introduced inadvertently by the DC in sometime the 42 to 1950 time range. And that had dire consequences for the native lake whitefish population. So they were in direct competition with one another. The Cisco also impacted the walleye population that was in the lake at that point. And kind of got us started on this trend. Rainbow smelt were also illegally introduced in the late 70s. Local fishermen lore have told me exactly how that happened. But that also led to a series of DEC management activities, including some stocking to take advantage of the really abundant forage provided by that smelt population. And then we have in 1986, so all of this is leading up to the alewife introduction in 1986. And so, like I said, we have tons of data. We are collecting information on every level of the food web, and we can put all these beautiful pieces of the puzzle together, but I'm going to use some shoddily produced graphics of the food web instead of some really technical graphs. So I just want to give you an idea of what exactly has happened over time related to the alewife specifically. So let's take ourselves back to 1985. I was not yet in kindergarten, but people here were studying the lake in earnest and finding lots of beautiful big daphnia. And the lake was relatively clear. We had a good lake trout population, it wasn't tremendously abundant, but it was there. Cisco were in place at this time as our kind of cold water planktivore. And there was someone doing research that stated, you know, if anything is to happen to this nice zooplankton community, I think the lake will turn green, essentially. I think Matt has the true quote later in his talk, so he'll probably a little bit more eloquent than that. So this is what we were looking at. Secchi depth measurements in the range of 4 to 6 meters most years, and good oxygen concentrations in the hypolimnion. Under the influence of alewife, so here's our alewife, we see a shift in the zooplankton community. Very few Daphnia remain, mostly dominated by Bosmina, copepods. We see the Cisco getting quite skinny. Their fitness declined as they were competing with alewife for that zooplankton forage. Alewife did become an important winter food source for the lake trout, and so lake trout abundance began to increase at this point. By the mid-90s, we start to have more of the results of this trophic cascade playing out. Transparencies were declining. We had a lot of algal production, mainly because of this lack of efficient grazers in our zooplankton community. So the Daphnia were drastically reduced, and the Bosmina just don't filter as much algae from the water column. So we have greening water, the excess algae is sinking down and decomposing, and we start to get oxygen loss. So what was a really great thing for the lake trout is now coming back to bite them late in the growing season in terms of a compressed habitat in the lake. I think in some years there were 5 to 10 meters of suitable habitat depth in the lake. And so their population was up, but they were stressed because of this confinement here. So just a little, I don't think I need to really talk much about the basics of alewife based on the group that's here, but essentially they were increasing the rate of phosphorus cycling. So the symptoms that we see because of this alewife introduction are the same exact thing that you would expect if concentrations of phosphorus were increasing. So directly, you know, they're a smaller fish, they're shorter lived than our previous planktivores were, and so we're cycling through phosphorus a lot faster than before, and it's essentially like loading with phosphorus. We see the shift from Daphnia to Bosmina. Why were they uncontrolled in Otsego Lake? It's largely due to the relatively simple fishery that we had in place at that point. Lake trout, cold water fish, alewife in the summer are isolated. They're up in the equilibrium and warm water. And so at that point, they're reproducing like crazy, and there's nothing there really to substantially make an impact on that population. In the winter, things are quite different. The lake trout are, you know, able to, we heard earlier about how effective the bottom trawl is because the alewife are following that warm water down to the bottom. That's also where the lake trout are going, taking advantage of that concentrated food source in the winter. And here's our esteemed director hoisting his trophy lake trout. They don't look like that anymore. So there are trade-offs, as we've heard. But this was during their kind of glory days. So we have 2 minutes left, and I have yet to do much of anything. Okay, so we see the spawning alewife increasing through 2000. 2000 is the year when the walleye stocking began. So up until this point, spawning adults are increasing. Walleye were chosen as a predator of choice for this control strategy. They had been present in the lake previously and thought they were a good overlap, and they should reverse all these impacts that the alewife had. And what we see in the spawning alewife is a continual decline in the spawning adults after the walleye stocking begins. And in terms of lake-wide abundance, these are acoustic-derived abundances. We see the peak at around 2002, and Mark's going to talk about this a bit later. Actually, you can see between the spring and the fall, light gray is spring, dark is fall. You can see that recruitment each year, and they're responding with increased recruitment effort in years when the predation is high. But once we get past the critical threshold in the spawning numbers and the waters begin to clear as a result of the zebra mussel filtration, we see a drastic decline in alewife population abundance. This looks even more squiggly when it's that big, but tells the general story of that cold water. This is the DEC Coldwater gill netting with our key time periods marked out here. Smelt introduction, alewife, the walleye stocking, and then the zebra mussels. So we see this boom in the lake trout population when the alewife abundance was really high, and subsequently we've seen a decline in alewife abundance. The condition of alewife or lake trout was pretty poor for a couple of years, but now seems to be rebounding. And so we can see these cycles of boom and bust with different effects on the food web. And since 2013, we've seen the zooplankton community rebound. You're going to hear a lot about that from Matt. Sam's going to talk about the potential for whitefish population rebound. We see cobble skills out there every spring looking at the smelt runs, and those are increasing as well. And Scott tells me that our lake trout condition is on the rise. So seemingly things have really come full circle, and this has actually worked. We didn't think it would work. I don't think we really thought at the outset that we would actually get rid of alewife. I think the idea was to try to find some level of balance, but lo and behold, with a two-tiered approach, getting them from the growing season with walleye and in the winter with the lake trout, it seems pretty effective. The zebra mussel invasion certainly makes it really hard to make any real statements that walleye stocking fixed their problem because all the anticipated effects of the zebra mussel are the same as if we fixed our alewife problem. So we really can't make any definitive statements there, but we're 6 years in past the zebra mussel invasion, and the conditions in the lake at every trophic level have kind of rebounded beyond what the reference condition was in 1988. So that's the quick and dirty of what's going on out in the front yard here. If I have time, I'll take a question. Yeah.